For almost a century, we have told the same story. Tyrannosaurus rex, the king, the apex predator of all time, the most dangerous animal to ever walk the surface of this earth. It is the dinosaur that fills our museums, the one that defines our idea of prehistoric terror, the one whose name alone is enough to make children stop and stare. But science, real science, the kind built on fossils and physics and decades of painstaking research, tells a different story. Because T-Rex was not the largest predatory dinosaur, it was not the longest, it was not, by the most critical measurements, the most dangerous. There was another animal, an animal that walked the earth 30 million years before T-Rex was even born. An animal so large, so strange, and so perfectly engineered for destruction that scientists are still struggling to fully understand it. Its name is Spinosaurus aegyptiacus, and this is its story. Before we can fully understand what Spinosaurus was, we need to understand what we are comparing it to. Because T-Rex is not famous by accident, it earned its reputation, and any animal we claim is more dangerous must be measured against everything this extraordinary predator was capable of. Tyrannosaurus rex lived during the very end of the Cretaceous period, between 68 and 66 million years ago. It was, in its time and place, the absolute dominant predator. Nothing in its ecosystem came close to challenging it. A fully grown T-Rex weighed between 8 and 14 metric tons, the weight of 2 full-sized African elephants. It stood 4 meters at the hip. Its skull alone was 1.5 meters long, roughly the height of an average human being. But the number that truly defines T-Rex is not its size, it is its bite force. 57,000 newtons. The most powerful bite of any land animal in the entire fossil record. Powerful enough to crush bone completely, not just pierce it, but pulverize it. T-Rex ate bone the way other animals eat meat. The marrow inside was the prize, and nothing in its world could stop it from reaching it. Its senses were extraordinary. Binocular vision comparable to a modern hawk, capable of detecting movement at extreme distances and judging depth with precision. An olfactory system so developed that it could detect the scent of prey from several kilometers away. Recent research has also suggested that T-Rex may have had lips, fleshy coverings over its teeth, similar to modern lizards, which would have protected its enormous teeth from drying out and kept them in better condition throughout its life. For 2 million years, Tyrannosaurus rex was the undisputed ruler of its world. In 66 million years of dinosaur history, no land predator in its specific time and place ever matched it. So why are we here, in this documentary, making the claim that another animal was more dangerous? Because dangerous is not a single measurement. It is a combination of size, weaponry, hunting strategy, ecological dominance, and raw physical capability. And on almost every one of those measurements, Spinosaurus scores higher. To find Spinosaurus, we need to travel back further in time than T-Rex, much further, 95 million years ago. The Cretaceous period, but not the world of T-Rex. This is the Cenomanian stage of the Cretaceous, 30 million years before T-Rex would evolve. The world looks different. The continents are arranged differently, and in what is now North Africa, modern-day Egypt, Morocco, and Algeria, one of the most extraordinary ecosystems in the history of life on Earth is thriving. Scientists call it the Kem beds, a geological formation in Morocco and Algeria that has yielded some of the most extraordinary dinosaur fossils ever found. In the Cretaceous, this region was a vast river system, a network of channels, floodplains, and coastal deltas, surrounded by dense subtropical vegetation and fed by seasonal flooding. It was here, in this lost world of ancient rivers, that Spinosaurus ruled. The story of Spinosaurus begins in 1912 in the Egyptian Sahara. A German paleontologist named Ernst Stromer von Reichenbach was excavating in the Baharia Formation when his team uncovered something extraordinary, the partial remains of a massive predatory dinosaur, unlike anything previously described. Enormous vertebrae, each with dramatically elongated neural spines rising up to 1.65 meters above the bone itself. A skull fragment with unusual conical teeth, unlike the blade-like teeth of most large theropods. Stromer named it Spinosaurus aegyptiacus, the Egyptian spine lizard. He recognized immediately that this was something different, something new. He brought the fossils back to Munich. They were studied, described, and placed on display in the Bavarian State Collection of Paleontology and Geology. Then, on the night of April 24, 1944, Allied bombing raids struck Munich. The museum took a direct hit. Stromer's Spinosaurus fossils, irreplaceable, unique, the only known specimen of its kind, were destroyed completely. For decades, Spinosaurus existed only in Stromer's drawings and descriptions. Scientists knew it was large, they knew it was unusual, but without physical fossils to study, its true nature remained almost entirely unknown. Everything changed in the 2000s when a series of new expeditions to North Africa began recovering additional Spinosaurus material. And then, in 2014, a discovery that shook paleontology to its core. Paleontologist Nizar Ibrahim and his team published a landmark paper in the journal Science, describing a partial Spinosaurus skeleton from Morocco. The specimen was extraordinary, and what it revealed overturned everything scientists thought they knew about this animal. Spinosaurus was not simply a large land predator with a decorative sail on its back. It was something far stranger. Something that had never been seen before in the dinosaur fossil record. It was semi-aquatic. Spinosaurus was the first known dinosaur to spend a significant portion of its life in the water. Its skeleton showed adaptations so clear and so comprehensive that the scientific community, after initial debate, reached a remarkable consensus. This animal was as comfortable in a river as it was on land. And that revelation, that Spinosaurus was not just bigger than T-Rex, but fundamentally different in its ecological role, is what makes it the most dangerous predator in the history of life on land and water combined. Let us examine this animal properly, feature by feature. Because the body of Spinosaurus is one of the most extraordinary collections of biological adaptations ever assembled in a single predator. Current estimates place Spinosaurus at between 14 and 18 meters in length, with the most recent and comprehensive analysis suggesting approximately 15 to 16 meters as the best estimate for the largest known individuals. By comparison, the largest known T-Rex, a specimen nicknamed Sue, now displayed at the Field Museum in Chicago, measured approximately 12.3 meters. Spinosaurus was, at minimum, 2 to 3 meters longer than the largest T-Rex ever found. In an animal of this scale, 2 meters is an enormous difference. Its weight is harder to estimate because its body proportions were so unusual. Current estimates range from 7 to 20 metric tons, the wide range reflecting ongoing scientific debate about the density and musculature of an animal whose ecological role was so different from other large theropods. The most commonly cited estimate is around 10 to 14 metric tons, comparable to T-Rex's upper range, but distributed very differently across the body. The most visually striking feature of Spinosaurus is its sail, the dramatic row of elongated neural spines rising from its vertebrae, reaching heights of up to 1.65 meters above the backbone. What was this structure for? Scientists have debated this question since Stromer first described the fossils in 1915. Several hypotheses have been proposed. The thermoregulation hypothesis suggests the sail functioned like a solar panel, absorbing heat in the morning to warm the animal quickly and radiating it in the afternoon to cool down. This is supported by comparisons to the Permian sail-backed reptile Dimetrodon, which had a similar structure. The display hypothesis suggests the sail was primarily for visual communication, used in territorial disputes, courtship displays, or species recognition. The high visibility of the sail from a distance supports this idea. A third, more recent hypothesis suggests the spines may have supported not a thin sail of skin, but a thick muscular hump, more like the hump of a bison or a large bovid, used for fat storage during seasonal food shortages. The scientific debate is ongoing, but regardless of its function, the sail made Spinosaurus one of the most visually distinctive animals in the history of life on Earth, an apex predator that announced its presence with a structure visible from hundreds of meters away. The skull of Spinosaurus is profoundly different from that of T-Rex, and those differences tell us everything about how it hunted. Where T-Rex had a massive, wide skull with bone-crushing teeth designed for maximum force, Spinosaurus had a long, narrow skull, remarkably similar in shape to that of a modern gharial or crocodile. Up to 1.75 meters long, but only a fraction of T-Rex's skull in terms of width and depth. Its teeth were conical and interlocking, designed not for crushing bone, but for gripping and holding slippery prey. Specifically, fish. Large, powerful fish. The kind that live in fast-moving rivers and can generate enormous force trying to escape. The nostrils of Spinosaurus were positioned further back on the skull than in most theropods, higher up, closer to the eyes, allowing the animal to keep its nostrils above water while its jaws were submerged. Exactly the same adaptation seen in modern crocodilians. Pressure-sensitive pits have also been identified on the tip of the Spinosaurus snout, similar to those found on the snouts of modern crocodiles, which allow the animal to detect movement in the water without seeing it. A sensory system perfectly engineered for aquatic hunting. The 2014 Ibrahim skeleton revealed skeletal adaptations that transformed our understanding of Spinosaurus completely. The hind legs of Spinosaurus were proportionally short, much shorter relative to body length than in any other large theropod. This would have made bipedal locomotion on land awkward and energetically expensive. But in water, where buoyancy reduces the need for powerful leg-driven locomotion, short legs are not a disadvantage. The bones of Spinosaurus were dense and compact, unusually so for a dinosaur of its size. Dense bones reduce buoyancy, allowing an animal to submerge more easily and maintain position in moving water without fighting the current. This is the same adaptation seen in modern hippos and some diving birds. The feet of Spinosaurus appear to have been broad and flat, potentially webbed, though soft tissue rarely preserves in the fossil record. A flat, broad foot generates more thrust in water and provides more stability on wet, muddy riverbanks. A 2020 study of the tail vertebrae revealed perhaps the most dramatic adaptation of all. The tail of Spinosaurus was not the stiff, counterbalancing tail of a typical theropod. It was tall, flexible, and paddle-shaped, with elongated neural spines creating a broad, fin-like surface. In water, this tail would have functioned as a powerful propulsive organ, driving the animal forward through the water the way a crocodile or a large fish uses its tail. Spinosaurus could swim, actively, powerfully, efficiently. This was not a dinosaur that occasionally waded into water to cool down. This was a dinosaur that was as at home in a river as it was on land, possibly more so. An animal's anatomy tells you what it can do, but watching it hunt tells you what it actually was. Spinosaurus lived in the Chem-Chem ecosystem, one of the most predator-rich environments in the entire history of the dinosaurs. Scientists who have studied this formation describe it as the most dangerous place that has ever existed on Earth. Multiple large predators competing for resources in a river-dominated landscape teeming with enormous prey. And at the top of it all, in both the water and on the banks, was Spinosaurus. The rivers of the Chem-Chem were not quiet streams. They were massive, fast-moving channels filled with some of the largest freshwater fish in Earth's history. Onchopristis, a sawfish with rostral teeth up to 5 centimeters long, reaching lengths of up to 8 meters. Morsonia, a coelacanth. Relative the size of a large great white shark, huge lungfish, schools of powerful, fast-moving prey that would have challenged any predator. Spinosaurus hunted these fish with a combination of patience, sensory precision, and explosive power. Wading into shallow water or swimming into deeper channels, it would hold its long snout just below the surface, motionless. The pressure-sensitive pits on its snout detected the bow wave of approaching fish. When prey came within range, the response was instantaneous. A lightning-fast snap of the long jaws, the conical teeth interlocking around slippery scales, the powerful neck muscles preventing any escape. For a fish the size of Onchopristis, up to 8 meters, weighing potentially several tons, this would have required extraordinary strength. The jaw muscles of Spinosaurus, while not delivering the bone-crushing force of T-Rex, were capable of generating enormous gripping power, the power needed to hold and subdue prey that was fighting back with the full force of a large, powerful fish in its own element. Recent isotopic analysis of Spinosaurus teeth has confirmed what the anatomy suggested. This animal consumed large quantities of aquatic prey. The chemical signature of its diet is closer to a semi-aquatic predator than to a purely terrestrial one. But Spinosaurus was not exclusively aquatic, and when it came ashore, or when terrestrial prey came within reach, it was no less dangerous. On land, Spinosaurus was an ambush predator. Its short hind legs made sustained pursuit across open ground difficult. This was not an animal built for the long chase that T-Rex was capable of. But near the water's edge, in dense riverside vegetation, it could wait with extraordinary patience for prey to approach the riverbank. The front limbs of Spinosaurus were large and powerful, far more developed than the vestigial arms of T-Rex. Each forearm ended in large, curved claws up to 38 centimeters long. These were not decorative. They were weapons, capable of pinning struggling prey, gripping the flanks of a large dinosaur, or hooking into the body of a massive fish. Smaller dinosaurs, pterosaurs coming to the riverbank to drink, juvenile sauropods, all of these would have been within range of a Spinosaurus ambush at the water's edge. And here is the point that separates Spinosaurus from every other large predatory dinosaur in history. It dominated two worlds simultaneously, land and water. No other large predatory dinosaur in the fossil record comes close to this dual ecological dominance. T-Rex ruled the land, mosasaurs ruled the sea. Spinosaurus ruled both the river and the bank at the same time, in the same body. That is what makes it the most dangerous predator in the history of life on this planet. By this point in the documentary, you are asking the question that everyone asks. If these two animals had met, if a Spinosaurus and a T-Rex had faced each other, who would have won? The answer, from a purely scientific standpoint, requires some important context, because these two animals did not exist at the same time or in the same place. Spinosaurus lived 95 million years ago in North Africa. T-Rex lived 68 to 66 million years ago in North America. They were separated by 30 million years and an ocean. They never met. But the question is still worth examining, because comparing them directly tells us something important about what each animal was built for, and therefore which was more dangerous as a predator in the broadest sense. On land, in an open environment, T-Rex would have had significant advantages. Its legs were proportionally longer and more powerful than those of Spinosaurus, built for sustained movement and pursuit across open terrain. Its bite force, 57,000 newtons, was likely significantly higher than that of Spinosaurus, whose long, narrow skull was not built for crushing power. T-Rex's skull was also built to absorb impact. The bones of the T-Rex skull are thick and reinforced, capable of withstanding enormous stresses. Spinosaurus's long, narrow skull, by contrast, was not built for direct head-on combat. In a direct confrontation on land, a bite from T-Rex to the skull or neck of Spinosaurus could have been catastrophic. On land, on flat, open ground, T-Rex was the more dangerous animal in a direct fight. In water, the equation reverses completely and decisively. Spinosaurus in a river is a different animal entirely. Its paddle tail drives it through the water with the efficiency of a large crocodile. Its dense bones give it perfect buoyancy control. Its long jaws and pressure-sensitive snout make it a precision weapon in an aquatic environment. T-Rex in deep water would have been in serious difficulty. Its heavy body and relatively short, powerful legs were not built for swimming. Its massive skull would have made keeping its head above water energetically expensive. It would have been at an immediate and severe disadvantage. In water, Spinosaurus would have dominated completely. But the question of which was more dangerous is not simply about who would win in a fight. It is about ecological impact, dominance, the breadth of an animal's predatory reach. T-Rex dominated one environment, the late Cretaceous floodplains of North America. It was the apex predator of that ecosystem. Nothing challenged it, but it was constrained to land. It could not follow prey into the water. It could not hunt fish. Its ecological dominance was, in this sense, limited to a single medium. Spinosaurus dominated two environments simultaneously, land and water, river and bank. It could pursue prey across both mediums, an ecological reach that no other large predator in the dinosaur fossil record has ever matched. On the specific measure of danger, of the breadth and completeness of predatory dominance, Spinosaurus stands alone. It is not that T-Rex was weak, it was extraordinary. It is that Spinosaurus was something we had never seen before and have never seen since. For all its power and adaptability, Spinosaurus was not immortal. Around 93 to 95 million years ago, the world of the Chem began to change. Sea levels were rising globally. A major marine transgression was flooding coastal lowlands across North Africa. The river systems that Spinosaurus depended on were changing, becoming more brackish, more fragmented, less productive. The great river ecosystem that had sustained the most dangerous predator in history was disappearing beneath the advancing sea. Spinosaurus disappears from the fossil record around this time. Not with a dramatic extinction event, not an asteroid, not a volcanic winter. Just the slow, grinding change of habitat that ultimately claims all species that cannot adapt quickly enough. And here lies one of the great mysteries of paleontology.
We do not have a complete picture of Spinosaurus. The fossils we have, remarkable as they are, represent only fragments of what this animal was. We do not know for certain how it moved on land. We do not know the full range of its diet. We do not know whether it was solitary or whether it tolerated others of its kind near its hunting grounds. We do not even know exactly how large the largest individuals grew. The upper estimates of 18 meters remain scientifically contested. Spinosaurus is in many ways still a mystery, an animal that science has only partially recovered from the deep past and whose full story may never be completely known. New fossils continue to be found. In 2023, additional material from Morocco added further detail to our understanding of its tail and hind limb anatomy. Each new specimen fills in another piece of the picture. But for now, Spinosaurus remains something unique in paleontology, an animal so different from anything that came before or after it, that every new fossil discovery has the potential to change our understanding of what it was completely. That is the mark of a truly extraordinary animal. T-Rex will always be the most famous dinosaur, and it deserves that fame. It was a masterpiece of evolution, perfectly engineered for its time and place. A crushing, smelling, seeing machine that dominated the last 2 million years of the dinosaur age with absolute authority. But Spinosaurus was something else entirely. It was an experiment, a biological leap into a completely new ecological space, the first large predatory dinosaur to successfully conquer both land and water simultaneously. An animal so specialized, so strange, and so effective that nothing in the 65 million years since has managed to replicate what it was. When you look at a modern crocodile, holding perfectly still in a dark river, sensing the movement of fish with its snout, exploding into action with terrifying speed. You are looking at the closest living echo of what Spinosaurus was: ancient, patient, effective beyond any need for fame. The most dangerous animal does not need to be the most famous. It needs to be the most effective, the most complete, the most dominant across the widest range of environments. By that measure, the only measure that matters in the natural world, Spinosaurus aegyptiacus was the most dangerous predator in the history of life on Earth. Not T-Rex, not Giganotosaurus, not any ocean predator. The spine lizard of Egypt, 95 million years old, still giving up its secrets to paleontologists working in the North African desert, one fossil at a time, the true king of the predators. If Spinosaurus changed how you think about the prehistoric world, subscribe to Jurassic Era for new documentaries every week. The prehistoric world has only just begun.